Okay, after we know significance figures and we know how to calculate the absolute error by using the approximations and the actual value. So here we need to understand another concept called the relative error. Now the reason why we need to know the relative error is in this table. So think of these two situations is that we have an MV saving and a Henry saving. And you can find that according to the formula of the absolute error, which is the actual value minus the approximate value, or approximate value minus the actual value, depends on which one is larger, you will find that for this situation, both of them is exactly equal to the same. But according to their actual value, can you iteratively think that which one is more accurate? Definitely, you will see that ME is much more accurate because relatively the error is much less than the Henry's one. Okay, if you still cannot understand, think of the situations that the actual value of the Henry is actually $8 and the approximation will be equal to 0, then you will find out that the absolute error is again equal to $8. But of course, you can see that the comparison between the 8 and 0 is relatively huge. So you can see that this AME is much more accurate. But how do we represent that mathematically? Instead of using the absolute errors to represent, is to utilizing the relative error concept. So relative error, let me abbreviate that as R dot E dot, will be equal to the absolute error over the actual value. Okay, so this is the equation for the relative error. Now, if you utilize this concept to calculate the relative error for ME and Henry, then you will see that the based on correcting to them to the three significant figure, you will see that for ME the relative error will become 0.00160, while for the Henry it will become definitely is much larger, 0.190. Okay, so you can see that the M is much smaller, so that's why it is much more accurate. But sometimes in the situations that we don't know the actual value, then what can we do in order to calculate the relative error? Now, so here we have another formula for the relative error. If we don't know the absolute error, that means if we don't know the actual value, actually we also don't know the actual value, right? So that's why the numerator and the denominator also don't know. So then we will utilize another formula. Now, normally the reason why we don't know the actual value is that we don't know the actual situation and we do some sort of measurement. So that means we know the measured value. Now after we know the measured value, and because the measured value we have a concept of the scale. For example, your ruler, your scale is equal to 1 mm, or sometimes you're measuring some sort of capacity or something, the scale is about 1 ml. So then you have a scale and then you will know that conceptually the maximum absolute error based on the scale. So here comes the relative error. If we only know the measured value is equal to maximum absolute error over the measured value. Definitely, you can see that for if the maximum absolute error, if the error is much larger, then the relative error is much larger. But in case for the measure, compare with the measure value, very similar to comparing to the actual value. So if the actual value is increasing, then the relative error will decrease a little bit. Just like for the MV situations, if the actual value or if the measured money is much more larger, then you can anticipate that the relative error is much smaller. Okay, so sometimes we will utilize the actual value as a denominator, but if we don't know the denominator, we will utilize the measure value as the denominator to calculate the relative error. Okay, finally, normally to represent the actual situations to human being, we will normally utilize the percent. Okay, instead of using so many. Instead of simply using the relative error, normally the relative error is more than 1. So here comes another formula for percentage error. So after finding the relative error, you simply multiply the relative error by 100%. So that will be the percentage error. Okay, so that's the concepts about the relative error and percentage error.